Okay, my name is Jitendra Tate and I'm a professor of manufacturing engineering at Ingham School of Engineering. I joined TXST in 2005 and started developing this lab. We call this lab as a Advanced Composite Lab, and we deal with fiber reinforced composites. We deal with various types of thermoplastic and thermoset materials along with this fiber reinforcement, and those reinforcement can be polyester, epoxy, vinyl ester, cyanide ester, like that, okay, high temperature materials. We do like a full mechanical characterization as well as thermal characterization, and mainly the main focus of the research is to develop the materials for various applications, like for example this fiber reinforced composites mainly for wind turbine blades, helicopter rotor blades like a fuselage, or ballistic impact panels. Okay, those are the main applications of it. Also, like, we develop various types of thermoplastic materials which are dispersed with various types of nanoparticles. It could be carbon nanotubes, nanographene platelet, nanosilica, nanoalumina, and all of that is to improve a particular type of property. So the material can be for electrically conductive to pass the ESD applications, or it could be for magnetic devices having a particular magnetic properties, or it could be like a heat shield material for space shuttle orbiter or deep space vehicles. So we do a lot of research in developing material for additive manufacturing, like well known as a 3D printing. So we do all these thermoplastic filaments, we do the liquids using UV radiation, we also do the paste printing. And again, the application could be, as I mentioned, it could be electrically conductive material, it could be magnetic materials, it could be for high temperature heat shield. We do a lot in sustainable materials, like we use hemp and ragweed and polyurethane, which is made of soybean oil. So likewise, and in this lab we use a lot of different nanoparticles, and we take very utmost care how we handle it, because we don't know what are the long-term effects of these nanoparticles. So I myself have involved a lot in nanotechnology safety, so where we have developed the protocol for various different types of nanoparticles, and I also represent School of Engineering at University Lab Safety Committee, where that's another major focus of my research. And this lab gets the funding from various agencies like National Science Foundation, Department of Defense, NASA, Department of Energy, US Department of Agriculture, and a lot of private companies like Evonik and KAI and Applied Nanotech and so forth.